Hi everyone. We are going to talk about two of the graph algorithms. We are going to visualize them. These are very standard algorithms which help us solve many problems of graph. So we are going to take a look at depth first search and breadth first search and visualize them how they are inherently different. So let's first begin with breadth first search. So this is the source and this is the destination. Our goal is to find the shortest path between source and destination. And this is an unweighted graph. So right now we are looking at the visualization of unweighted. So let me bring my destination somewhere here. Okay, so we start here and we have to reach here. And what we are allowed to do is we can move from any cell, we can move either up or left or right or down. So these are the four directions to move. And one more thing, we will follow one order. That means from here you are going to go one step up. First option will be to move up if that cell is not visited already and if that cell is available. Then second preference will be going right. Then third is down, fourth is right. So it's basically up and clockwise. So if we see how breadth first search proceeds to find the shortest path, um, it it simply keeps expanding to neighbors and their neighbors and their neighbors. So you can also visualize it like a ripple effect. If you throw a stone in the water, how the ripple effect is seen, how that spreads. So that is how the breadth first search works. And usually breadth first search is a preferred algorithm when you are finding shortest path in unweighted graphs. So we will see its execution. So let me just first go with fast. Let's start. If you see, breadth first search ended up visiting these many nodes and ended up finding this path. And it took just 0.14 milliseconds. And in 34 steps, it could find the shortest path from here to here. Same way, if you go to depth first search, let's see what depth first search does. So depth first search goes like up, up, up because they were available, then right, right, right. When up and right are not available, goes down. Same way it continues, and when it hits the destination, it stops. So you can notice that in this particular example, that it has taken more steps than the breadth first search. Now, just to visualize individually like how they proceed, so let's go with little slow motion. So this is one cell where it originates, where we start. Let's first visualize how breadth first search works. So we move up first, then right, then down, then left. Then we go to upper cells neighbors, then we go right cells neighbors, and that is how neighbor by neighbor we keep expanding. So let's see. We started with center, we went up, right, down, and left. Now for here, go up, right, down, and left. So for every cell, which was visited earlier, we are sequentially like going and visiting their neighbors. And we will stop once we hit the final destination. And once we have the destination, as part of BFS and DFS both, we keep track of like if we landed at this cell, it is because of which neighbor. And that is usually called the parent cell of it. And parent cell is usually useful in getting the path back. So this was the path. So this cell knew that I was visited because of this parent. This cell knew I was visited because of this parent. This cell knew that I was visited because of this parent. And this cell is the start cell anyways. So this is the path that BFS has given. Now, if we try to visualize how depth first search proceeds, then we will notice that if we see it in slow motion, that we are going up, up, up. Then because here upsell is not possible, second preference, we go right. Then for right, again, same thing, we continue moving right. So if you see depth first search, ideally the way the code is written is DFS has been executed, solution has been generated. We are now just rendering that solution. So, so there is a separate function that completes DFS, generates the path and passes it to the UI. And UI takes the solution that our code has generated and just takes care of rendering it at a slower speed or faster speed so that we can visualize it better. So if you see, if we go with depth first search, this is the way we will say like, uh, I found this over here at the time of executing depth first search. So this completed in 43 steps, and this is the time taken. Yeah, so graph is exciting. In graph, there are a lot of applications, a lot of real world scenarios. For example, if you have flights from one city to many other cities, and you have to find a least cost flight where we are allowing user to take one hop or two hop, one stoppage in between or two stoppage in between. Those kind of algorithms are used by all flight booking sites like yatra.com, makemytrip.com, Kayak. So there are exciting algorithms we are going to talk about in Graph. In case you are interested, we have an upcoming batch of cracking coding interviews where we do cover all the algorithms starting from fundamentals to graphs, trees, dynamic programming. So this is a comprehensive course that helps everyone prepare for their interview. So if you are interested, you can check the description below where the link is provided to enroll for the upcoming course. So it is going to start in next couple of days. So if you want to be a part of this exciting journey and take your coding to the next level, we are looking forward to you to join our course and be part of this meaningful journey. So cool, that's it for now. Thank you for watching. Hopefully we will see you in the next video as well as in our next batch. Wishing you a happy day, happy coding, and a happy life. See you again.